this computer. You all able to see my screen, right?
Yes.
All right, thank you. All right, just simply I design a question based on my experience. So the pacer selection for the Standard Chartered KL Marathon, right? KL Standard Chartered Marathon. They must go through an assessment run where they are required to run an assigned pace, right, for 10 rounds. And it is 1 kilometer per round, totaling 10 kilometers. So 10 times 1 is 10K. The data below shows the measures in seconds. So there are two runners here, runner 1 and runner 2. And what you are required to do is to say what type of data is this. All right, what type of data is this? So we should know that this is time, and we have to measure the time, right? We do not count. So I guess everybody should know it is actually a quantitative data, and quantitative we have two. What is one is counting, the other one is by measuring. So we are measuring, therefore is continuous, right? It's continuous data. And then you need to do the, for both runner, you need to get the measure of central tendency. Central tendency is your mean, median, and mode, all these three things. Mode, you can just look at the highest frequency. The highest frequency here, I believe, is mode is, if you look at thing, is 340. You have 1, 2. Do we have any other repeating numbers? So we don't have any other repeating numbers, and it's also same thing for the mode. For the runner 2, also 340. Okay, the mode is done there. Median is rather difficult for us to do it manually because they are not in order. Okay, they are not in order. They are kind of, because every round is, this is the number of round, round 1, round 2, and so on. It is that's in order, but the data that we obtain not in order. So the best thing for us to do here is to key in the data in L1. Now here we have two data. Instead of wasting our time doing it 2 times L1, we can key this into my L1 and I'll key this into L2. This is not bivariate. All right, this is not bivariate, but just to make life easier, we will do that in L1 and L2. Okay, remember this is not bivariate, it is univariate. Because we are not finding the relationship between the runner 1 and runner 2. Okay, we are just looking at independently. The reason why I put L1, L2, so that is save our time. So stat, you'll go to edit. I think by now all of you should be very good at it. Never mind, let's show this 330. First round 330. Second is 335. Okay, 340. 345, 340, 343, 346, 350. Now remember, the bigger the value means the person runs slower. 370 and 360. Then go for the runner 2. We're just going to put it together one shot. 345, 340, 343, 345, 340, 338, 339, 341, 340, and 342. Okay. So we have two runner one and runner two. Actually, you can rename runner one, runner two, but that's just gonna waste our time. You're not gonna bother. So remember that this is the runner one, runner two. So what we're gonna do is the same things that we're gonna go to calculate, and we're gonna do one var stat. So we will do for runner one. Okay, we will do for the runner one, and you can copy the value because we want the mean. All right, 345.9. And the median, you just have to go down, okay, 344. Okay, but if you see the questions, they also want the 5-number summary, right? You also can copy the 5-number summary. The n is 10, minimum is 330, q1, q3, and maximum. All right, now I'd like to get your attention. This sum is the total of all your x. If you add up all your x, you'll get 3459. Total is 3459. If you take that 3459 divided by your n 10, you'll get 345.9. Okay, in this case, it's divided by 10, so it's straight away no issue lah. And for the standard deviation, you read the SX only. All right, not the sigma x. Okay, so let me just copy this, and then we will do the same thing for the runner 2. For that, we'll do that stat, calculate, go for number 1, but instead of L1, we're going to do L2. Remember, this is not bivariate, univariate. We just put the data together. If you're not comfortable with this, you can delete your L1 and then rekey in your runner 2 there lah. All right. And this is for runner 2, the same thing. Just copy that. All right. So you have the data, or the outcome rather, and central tendency. Okay, if you have done it, you should be able to check. It'll be probably depends on the questions. It'll be nicer if you can, if it's what you call a hybrid, you can give in terms of tabular form, right? I have my runners, and then I have them, what I need to do, mean, median, and mode. Those are the data lah, right? Those are the data. Where is this thing? This is control copy. Okay, I'm just going to put it down. Let's put it in the table. So insert. That's the runner 1. And control. That's for the runner 1. And then we will do the same thing for runner 2. Copy E. Control E. Okay, so the data is here. So you'll have, make sure they are same, huh? And like I mentioned many times, make sure that you always double check, is if not triple check, huh? Your data, one error, the value all will be wrong. And when the value is wrong, everything is going to be wrong. Okay, so we got that things done, and everything, the units here should be in seconds lah. All right, units should be in seconds. All right, let's put as lah. All is seconds. Okay. If you have a question, you can just stop and unmute yourself and ask. Next, they ask the 5-number summary. The 5-number summaries are also the same. I got make sure you arrange in a sequential form. Minimum Q1, median is also known as Q2. All right, Q2 or median, Q3, and maximum. All the units are in seconds. All right, so you just add in the seconds there. Okay, they are in seconds. If you ask the importance of units, will we minus your marks? Likely no, but the right thing to do lah. So we have done the measure of central tendency, that is the mean, median, and mode. We have done the 5-number summary, that is just the mean, Q1. This is minimum, Q1, median, Q3, and maximum. Next, they ask you for the dispersion. All right, how is it being dispersed? There are a couple of measures for dispersion. First is the standard deviation, range, and then you also can mention your IQR. Now the variance is actually tied up to your standard deviation, so no need to write the variance, right? Unless it's been asked. Now for the standard deviation, all right, for the standard deviation, you will read the SX. You will read the SX. Standard deviation, you will be reading the SX. Okay, you will be reading the SX. Why both are the same? Copy the same thing. What's happening? Oh yeah, okay, that's the runner 1, runner 2, right? This is runner 1. Okay, this is 1, this is 2. So the runner 2 you have, and runner 1 is 11 point something. All right, they're the same thing. All right, same thing. You read your SX. You read the SX, not sigma. Please be mindful. You read the SX, not the sigma. Okay, not the sigma. Read the SX. So you have the standard deviation. That is your S. X. Okay. All right. Read the SX. IQR, you know that is Q1, Q3, sorry, Q3 minus your Q1. If your data wrong, your Q1 or Q3 will be wrong, IQR will be wrong, and then of course your outlier also will be wrong. Now the formula for outlier, you must know how to calculate the bound. All right, the bound is, lower bound is, you must know that is equivalent to Q1 minus 1.5 of your IQR. Okay, and your upper bound is the same thing, not the same thing, similar, which is your Q3 plus 1.5 of your IQR. Right? And you got that value. So your data should be within this bound, lower bound and upper bound. That means no outlier. So we have 370. So 370 would be your outlier. All right, 370 would be your outlier. For data 2 or runner 2, Do the same thing, repeating the formula, and you have all the data within the bound, so no outliers. All right, there's no outlier. You must tell no outlier. Don't leave it empty, because you do not know what your empty means. Okay, explain with explanation, state which better measure of spread. Now, better measure of spread is always depends whether there is existence of outlier or not. You have to check the existence of outlier. All right, need to check for outlier first. So that's why I already asked, if you have outlier, IQR would be better. Okay, this is for runner one. IQR would be a better measure of spread for runner one, while standard deviation for runner two. Why standard deviation for runner two? Because runner two, as there is no outlier. Okay, in this case, as there were no outlier. Okay, when you don't have outlier, standard deviation would be a better measure compared to IQR. Range is not, all right, range is definitely not, because it is maximum minus the minimum. So it will definitely be worse than IQR. You are required to draw the parallel box plot. Right, the parallel box plot. I think you are able to draw the plot. The plot are going to be quite, one is quite long. The other one is very tiny. Okay, draw the box plot. So make sure you do this. Okay, it must be use scale and ruler. Use scale and ruler. You should be able to do this. Drawn, but I did not take the picture. So let's just give you a simple drawing. Insert shape line. Okay, and then I'm gonna put in a box. Theoretically speaking, the size, the thickness and the width of the box should be the same. Line to this side, a line to this side. Oh, this okay. And the lines here is a bit shorter. I need to readjust this. Okay. So the minimum here we have, right? The minimum here is maximum, and we have outlier. Okay, outlier that is 370. 370, that's 360, I believe. Yeah. 360. Okay, because we found the outlier, so you include the outlier in your box plot. Your Q3, 350, 360. I think it's not really into a scale, so you should do according to the scale. 350. Median, 344. All right, 344. 340. And 330. whereas this is 3. We need to shift. Does it move all together? Are you? It should be a bit more smaller. I'm drawing better, right? Okay, both has same Q1, so I think mine is perfect. Okay, this is 340. The median is closer to here, which is 340.5, and that is Q3 343. The maximum is 345, should be slightly shorter. So that's 344, 34. Sorry, slightly longer, my bad. It's not listening. Okay, should be about that now. 345, and the minimum is 338. Okay, 338. Something like that, huh? Okay, the N is filled in bubble because that value is inclusive. Now, they always asked you to describe. So in this case, the description, I think it's pretty obvious kind of box plot. The first, this, okay, what is missing? I did not label. This is my runner 1. And this is my runner 2. Right? So it's pretty obvious that the runner 1 is too much of variation, right? There's too much of uncertainty here from 330 moving all the way to 370. There's a lot of variation, whereas the runner 2 is very less, okay, very less or very consistent, right? Very consistent. And the similarity that if you're looking for is only same as Q1. Okay, you don't tell that Q1 is 340. What does it mean? 25% of the runner, sorry, not 25%, 25%, sorry, it is 25%. 25% of the running time or the laps, all right, 25% of the rounds for the runner 2 and the 25% for the runner 1, they both have ran below 340. Okay, below 340. 25% of it they have ran below to 340. So 25% of the running times, run times were lesser than 340 seconds for both runners. Okay, 25% of the running time, okay, or the rounds, right? Running time, that the time, the 340 and whatever times were lesser than 340 seconds for both runners, which is runner 1 and runner 2. In terms of the quartile skewness, okay, quartile skewness, you can see that runner 1 is almost symmetrical because that's my drawing is a bit out, I guess. 340, there's only 4, and here is 6. Okay. I use the word almost, but if you are not comfortable with that, you also can say it is also right skewed. Okay. You also can just say right skewed. Huh? Okay. You also can say almost symmetrical. I also can say it is also slightly right skewed. Okay. Or if you use the word right skewed, I think at this point they will not really look into the details. Huh? My drawing is a bit out. Huh? Scaling is out. Yeah, this is 10 and here's another 10. Huh? So yeah. Almost all the time, the runner 2 were faster than the 50% of runner, the running time of runner 1. Right? Running time of runner 1. What does it mean? What does it mean? It means that almost all the running time, right, were lesser than 344. I use the word almost because 1 is 345, 1 second more. So that's why I use almost all. Running time of runner 1 were faster. Huh? The word here should know is faster, not slower. Less time means it's faster. Then the 50% of the time. Why is it 50%? Because the median for the 50% of runner 1 is 344 and the maximum for this is 345, so everything is lesser. So you got to compare the quartiles. Huh? You got to compare. So I'm comparing the whole of this 100% is lesser than 50% of this. Okay. Of course, you can mention about the outliers. Okay, one has outlier, the other one has no outlier. Okay, skewness you already mentioned. Are we okay? Any questions for this? All right, explain. This is a bit out of, maybe you all do not know what it is. Sometimes the general questions, yeah, common sense comes out also. All right. So it should be runner 2. Why? Because the running time were very consistent as the standard deviation or very small. Okay. Is very consistent. I think should be N, not. So just for your knowledge, pacer means that we must run in a very constant pace throughout the run, right? So if the other runners follow you, they should be doing it. This is actually for a marathon 4 hours, okay, and a marathon for half marathon for 2 hours. So if you follow these paces, you should be able to do the half marathon below 2 hours and marathon below 4 hours. So if we cannot run as a pacer, you cannot run like runner 1. Okay. Suddenly you run very fast and then decided to run very slow and then you're fluctuating up and down. So it's not. So it is like you are driving at a very constant speed. So you must run at a very constant pace as a marker for other runners. So that is just the meaning of the word pacer. All right. Are we okay with that number 1? All right. Number 2. Number 2. Simply look at the data. I don't think so. The data is accurate. I just modify here, there a bit. So to suit the, looks nice. The gold price, okay, with the current use into the electronics, the price actually gone up so much. But still, gold are mainly used now. Almost 70% of the gold is still used in the jewelry. Another about 25% is used as the currency, yeah, the gold coin and things like that. And only about 5% is being used in electronics, just for your knowledge. Huh? All right. In this case, we have two, and you got to read very carefully the price since 2010. All right, the price since 2010. So this is not your random variable. Your random variable here should be your T. All right, your T, that is 3, 4, 5, 6, 7, 8. All right, yeah. 9, 11, 12, 13. Okay, so that is your random variable. Why? Because it's since 2010. So 2010, that is T equals to 0. If you put 2010, your gradient will be okay, but your y-intercept will be wrong. Okay, your y-intercept will be wrong. So you have to define the independent and dependent variable. Now, independent, of course, something controls the other one. So the time affects the gold price. Gold price doesn't affect the time. So your independent is year since 2010, right? And dependent is gold price, right? The price. By the way, this is RM. Took the data from Maybank. All right, obtain the scattered plot using your GC and comment on the relationship. This seems to be the kind of question nowadays. They did not really ask you to plot, but if you are asked to plot, you should be able to plot. And currently, we only give you an empty A4 paper, so you should just use your ruler and draw lah. But that's not the things. It seems to be not lah. Seems. Don't tell me. I mean, I don't want to say it's not, because suddenly they ask you to draw. So go back to your GC, right? Go back to your GC, stat, and then you need to edit. Now make sure you clear them first. There are a couple of ways of you to clear. I always like to do this. Go up to L1, press clear, push it down. It's empty. Don't delete one by one. Wasting time. Clear, press down. Make sure the cursor at the first column or first cell. If you have any other data, then you're going to make it wrong. So you're going to enter 3, 4, 5, 6, 7, 8. 8. I don't have 10, right? 8, 9, 11, 12, 13. Okay. Push it to the other side and key in the price 138. Enter 140, 145, 160, 161, 170, 170, 200, 241, 241, 260, 300. Okay. Now, once you have keyed in, make sure that you double check your data. And when you check as horizontally, 3138, 4140, and so on. Once you have keyed in, you second quit. You go to the mode first, and then on your diagnostic. Okay, go to this and on your diagnostic. Second width, and then you're gonna go to second y equals 2, and you're gonna go to number 1 on it, and it is type 1. The defaults, everything is by defaults, and then zoom 9. Okay, all the steps were given, so you do have the plot. The plot is positive. Okay, and it seems to be non-linear. Okay, the line is the dots or the points are not aligned as a linear or in a straight line. Okay, so you have to comment, obtain the scattered plot comment on the relationship. The relationship, you're gonna say there is a positive and non-linear, right? Non-linear relationship between the gold price and the year since 2010. If you are asked why, then you can say the points. All right. Reason you can say lah. If you want to know the reason, as the points are not scattered. Right. Not scattered in a straight line. Or almost a straight line. So it's not in a straight line. They are not scattered in a straight line. Okay. I think that's you need to find the regressions coefficient. Regressions coefficient is the value of the gradient. All right. Regressions coefficient is actually the slope. Okay, this is the slope gradient and your y-intercept. Okay, slope and the y-intercept. So what I've done here. See missing. All right, the A is your A. If you do that, okay, sorry, I did not do that, right? So what I'm gonna do here is take that picture. So done. Next is you're gonna go to second quit, stat, calculate number 4. You can use 4 or 8. If you don't want to confuse with the question, you just see whether the question wants in ax plus b or a plus bx. Both are the same. But the value of a here is the value of b. Okay, a here is a gradient, but here b would be the gradient. But this a and this a not the same. They will not be the same. Right, I'm going to use number 4. Why is it all L2? Second, X list must be independent, L1. Y list is L2. Frequency is no need. And then I'm going to use store alpha trace 1. Calculate. Okay, so I got these values. Okay, I got these values. Let me just put it in. Graph E. Here. Hey. Okay, and you have this. So the value here, it depends on how many decimal point they want. So you follow through lah. All right, it's follow through. The value seems to be quite nice. They are about the same, the decimals. So the A is 15.9091. I give in 4 decimal places. It is about the slope. This is actually the slope. A is the gradient. So we are talking about the equation of the regression. So the regression line or regression model, all right, predicts. B should be down. I think I've not finished this answering. Okay, let's do it together. So the value of A is the regression model predicts, right? It's about prediction. The linear line is about prediction, predicts on average. Okay, it must be on average. On average. What about on average? There is an increase. Okay, an increase. How much of RM? 15.91. Money is 2 decimal per year. Are we okay here? It is important for you to mention the regression line or the regression model predicts. All right, the word here, the predict. This is important. The regression model, it predict and on average, whether increase or decrease amount per whatever the independent units. Are we okay? Right. No space. It's supposed to. Okay. Whereas the B, it is the y-intercept. Of course, it's y-intercept, but if you say it's y-intercept, you get nothing, right? So this is the price of gold at at year 2010. All right, the price of gold in the year of 2010. Okay, in the year of 2010 is the price of gold. The year of 2010, which is RM 67.41. I think I'm missing something. What am I missing? It's the predicted. That is the predicted gold price. It's the predicted gold price. It is not the actual price. It is the predicted gold price, the year of 2010. Okay, the word here, again, you need to have predicted. Okay, the predicted gold price in the year of 2010, which is RM 11641. Are we all right? 63 people. Okay, no. Right. All right, next, let's move on. State the coefficient of correlation and then interpret. Be careful, they're all the same. Don't get confused, put the wrong value at the wrong place. Coefficient of correlation is actually your R value. Okay, your R value, let's say we give this in the form 4 decimal places. R value is 0.9592. 0.9592. Right. Yeah, 9592. What does it mean? It means that even though we found just now not linear, but our linear regression says is very strong. Okay, you will say there is a strong, okay, positive, and you must say linear. Although we say just now non-linear, here you must say linear. Why? Because you are doing linear regression here. Okay, you are doing linear regression. This value is for linear regression. Okay, you must say linear regression. It is linear regression. Ramai. Yeah. Strong, positive, linear correlation. Actually, it's supposed to be association. Association. That's the right word, association, but you can say relation and positive linear association between gold price and what is this? What is this? And year since 2010, right? And time since 2010. I think it's supposed to be years since 2010. Careful, you must mention linear. Although we say that non-linear. Okay, that is just by eye. It seems to be not linear, but here it is. Quite strong value. State the coefficient of R, coefficient of determination. Determination means is your R squared. Okay, that is your R squared. R squared. R squared equals to, should have it here, 0.9201, 9201. 0.9201. What does it mean? We can say 92.01% of the variation in the gold price that can be explained by the variation in the year since 2010. Okay, 92%. Very good, very good. But we still have 8%. Find the gold price in the year 2011 and 2020. 2011, and then you state the reason, with reason, comment on its reliability. Reliability, this is 11 and 20, right? So you're gonna go to the calculator. Second, calculate value. You want to put in, you must have the line in order to do the calculation. If you know line, you cannot do this. All right, that means you did not store your into your y1. Right, so when you put in here 11 means it's 1, and it comes out like this. That means our window is too small. Press 2 and then go to the window. You just have to make it your x minimum maybe 0 lah. And then you do your second calculate. value, if you put 1, you got 83.32, right? 83.32 lah, money to decimal lah. So you have, I do it here, okay. RM 82.32 are you? Is it correct? 83.32, 83.32, 83.32. See the errors. Okay, this is in the year 2011, and for 2020 would be 10, right? 2020 will be 10. You actually can just key in another 10. I don't need to do second calculate one more time, and then enter. It is quite nice, 226.5. Okay, you have price is RM 226.50. With reason, comment on the reliability. So you're gonna say that the price in 2011 is not reliable, huh? All right, not reliable. As what? As as 2011, say 2011 lies outside the data range. Outside the data range. Why is it so important if it's outside the data range? Okay, when it's outside the data range, the pattern, all right, the pattern or the model may not be the same. Okay, there are times the gold price have dropped tremendously. Yeah, there are times gold price dropped tremendously. So maybe in 2010 the gold price probably higher. Okay, probably high. We do not know. We do not get the data. We have is it seems going down from here going up. Maybe in 2010 the price, or 208 the price is very up there and then coming down and then picking up. We do not know. So the pattern, we do not know the pattern. We only know the pattern from the within the data range. We know the pattern. Outside the data range, we do not know the pattern. Okay, so we do not know pattern where the linear regression, I wouldn't say where the pattern, right? Where the pattern of linear regression may not be true, or may not be true, or may not true. Okay, and extrapolation is needed. So it is important for you to mention the pattern may not follow, the pattern may not true, the pattern may not the same. Okay, we are not aware. I think my classical example is when you boil the water. Of course, when you draw the graph, it will be linear. And if you boil it for 2 days, the temperature using the regression will be very high. But we all know that the temperature of water cannot exceed 100 degrees Celsius. Okay, so the pattern, right, the trend, right, the pattern or the trend may not be the same. And price in 220 is reliable, as 220 lies within the data range. Within the data range. What about it? So it follows, all right? It follows the trend or the pattern. Okay, because we know there is no sudden influx or sudden increase or sudden decrease in terms of the price of gold. 20 is here. We do not, we know that it's just going up. There's no suddenly going up and coming down or whatever. We do not. Although that's 2020 is supposed to be a COVID year. Okay. Follows the pattern or trend of linear regression. Or linear regression. That is your interpolate. Interpolation. Are we okay? Where the pattern of linear regression. Okay, I think I'm wrong here, right? I'm not putting what I'm saying. Where the pattern of linear regression. What I said, may not be. I think may is not there. May not be true. Or is not true, or is simply doesn't follow. We do not know. All right, this is a very standard question. All right, very standard question. And yeah. Next, again, you just use your graphing calculator, obtain the scattered plot, what conclusion you may draw on the residual plot. So you got to go to your Y L2. Okay, you got to go to L2. Okay, you got to go to L2, stat, edit, go to, sorry, L3, go up. You will key in your actual value is L2 minus your residual value, open bracket, key in the equation. It is actually 15.9091 X, or in this case the T, which is located your independent L1 plus 67 point, I hope my values are correct, 0.4091. Close your bracket, enter, the value drops. And at glance, this value, you can see that's positive, positive, negative, positive, positive. So it is actually will be a U shape. Okay, above x-axis, below x-axis, above x-axis. So if I go to the residual plot, second y equals to plot 1, second 3, zoom 9. I have this, I put zoom 3, oh God, zoom 9. So we have what we call a clear pattern here. Okay, we have a clear pattern here. Insert box. clear pattern. So you're gonna say obtain. Don't need to draw, huh? You just have to obtain, and then based on that, you just give putting it here for reference. So from the scattered plot or based on the scattered plot, based on our scattered plot, sorry, it's residual plot. Residual plot obtained, right? The plot shows what the plot is showing. The plot shows what? The plot shows an obvious what? Pattern. What pattern is it showing? It's showing a U shape. Okay, it's U shape. Okay, what about U shape? Okay, the plot shows an obvious pattern. We can see there's a U shape. That means it's not randomly scattered. Okay, means you don't need to put the not randomly scattered. If you want, you can just write it that type. I mean, you write it that and draw the conclusion. Therefore, you can say what's happening. Therefore, you can say the linear regression is not suitable. Okay, the linear regression not suitable. It should be therefore, huh? Therefore. Are you okay? You have the U shape, huh? The U shape. No need to look for perfect U, huh? It's just as long as it is above, below, above, or below, above, below. Randomly scattered will be below, above, above, below, below, above, above, below, above, below, above, below, above, like that. Huh? In this case, it is not. So conclusion is done and the residual plot, okay? So it's not suitable. So then Mr. Gold applied linearization and he thinks would be better model, okay? And he obtained that ln P is equivalent to this. Explain with evidence why linearization will be a better model. So what you're going to do is that in this case, you need to work out a bit. They already got the answer for you, but you still have to do because you need to have the evidence. Okay, I don't have the evidence. We only have the answer. So the evidence here, you need to plot, right? You need to plot ln P. Okay, ln P for the price versus T for the time. Okay, ln P, I need to plot ln P versus T. Are we okay? So you're going to go to the GC stat because we need to have the ln. Go to number 1, edit. We don't want the residual plot anymore. So I'm just going to clear it off. I'm going to go to L3. I'm going to make it ln. Okay, you got to see carefully whether it's log base 10 or log base E. So ln is base E and L2. All right, so you enter, you got that value. So now you're going to plot your graph. Second y equals 2, plot 1, and it is already in L3, zoom 9. Zoom 9. Is this correct? Yeah, this looks a bit all right. Yes, correct. It's under the value of launch. So it looks a bit okay compared to earlier. And to get that equation, we're going to do calculate. Go for number 4. And then you're going to go to y least is L3. Okay, I can store the equation alpha trace. I'm going to put it in 2 and calculate. Lama, I did not take the picture just now. Okay, never mind. Okay. Explain with evidence why linear regression would be better model. So in this case, I'm going to put it that in and alama. Sorry, yeah, just insert and then box 2 x. So we're going to compare. The thing is here, is this the answer given? 0.742, yes, correct lah, huh? 911, okay, correct. We're going to compare, in this case, the better is in terms, better model, you are required to compare the R value, okay? Compare the R value. Okay, you need to compare the R value of the two model, huh? Need to compare the R value of the two models. So you probably can say your linear model just now, right? The linear model. Linear model or linear regression, it doesn't matter. You have your R equivalent to, what is it? 0.95 9592, and for the lawn model, right? Lawn model, you have your R value equivalent to 0.9783. So 9783. So by looking at the comparison, you can say that, okay, you can say the, can I label it to the subscript? Subscript, put it. Oh, man. So you can say that you can say the R value you can say the R value of the lawn model is much closer, because both is actually close to 1, all right? Or you can say it's greater also can than the linear model, closer to 1 compared to linear model, R value of linear model compared to R value of linear model. That's one. Or you also can say, I'm just going to write it down. You also can say, right? You can say that that 0. 0.9783 is indeed greater than 0.9592. Okay, it's indeed greater. You must make the comparison, huh? You must make the comparison. Compare the two R value. If you have 3 model, you compare the 3. You have 4 model, you compare the 4, and so on. This is what we used to do back then. Huh? Get the model and then you keep on compare until the one which is actually better. Actually, this loan model also not good model, but I'm not going to discuss about that. Okay, it's not a good model. So the linearization process will probably use x squared or p squared and things like that, or square root and so on. Yeah, but we are not doing that. So find the p in terms of t. The equation was, where is it? Write it down. Oh, it's here, right? The equation is, we have your ln p, which they already gave you actually, right? Ln p. I can copy and paste them. Yeah. It's p, right? So let's do the bring the ln to the other side. So your p should be equivalent to e power to 0.07942 t plus 4.5991. So that means plus means multiply e power to the 0.07942 t plus means multiply e 4.5991. Okay. And then you use your Casio, use your Casio, enter the value. Okay, enter that value, your Casio, and you should be able to get what am I doing? Second ln, enter the value 4.5990888345. So we get 99.39. So this is going to be, you can put the constant or the coefficient in front. So that's 99.39. Okay. E power to the 0.07942 t. Okay. So that is the exponential model that we're supposed to get. Are we okay so far? Any questions? These two questions are quite substantial for the. Any questions? All right, no, good. I just managed to figure out some MCQs. So let's just look at this. Whoa. It's already been 1 hour, 20 minutes, huh? All right, the stem and leaf plot. All right, the stem plot, stem and leaf, shows the age of 19 people in a bus. Quickly put only. 2/1 means 21, and in this case, you got to see there are 2, 2, 3, 3, 4, 4. Huh? So that means it's only going up to 0 to 4, 5 to 9. Huh? Median of the age. Now you can key this in your GC and take your time, but I think that's quite going to take up a bit of time. Gonna cancel 1 here, 1 there. But you got to be very careful. The second one, you cancel this, not the 1, but you must cancel the 2 here. Okay. Then you cancel the 5, you cancel the 2, cancel the 7, cancel the 2, 9, 1. Okay. This side is 1, you cancel the 9, 3, 9, 3, 7, 4, 5. So left is 36. Okay. That's quite straightforward. So 36. The variable marks obtained in a test and amount of time spent on the revision. So test marks obtained in a test is your dependent, and the time span, that is your independent. Okay. Are strongly correlated. Okay, strongly correlated. I think the word is should be not strongly. It's only 0.78. Should have used the word strong, or the word strongly, strong. Yeah, I think language. Yeah, I'll leave it. We can conclude, this is 0.7. We can conclude increase in the spending time on revision will increase the test mark. Sounds a bit okay. Let's see whether we have any better option or not. 78% of variation, definitely not. It's not about variation. This is about R squared, so definitely no, it's not. The amount of time spent on revision by the student is 78 point. This marks is not. Increase in spending of time in revision are associated with the increase in marks. This is sounds more better compared to the first one. Spending time will increase, okay, the test marks, but I think the keyword here is associated. So increase in spending time, all right, spending time, we go higher, is associated with the increase in mark. Both is increasing. Why? Because it's positive. Okay, I think I mentioned that your X increases, Y also increases. They also can say your X decreases, your Y also will decrease because it is positive value. So the perfect answer should be D. Okay. This is such a big gap. We have two type of parallel box plot. We have just now also one. We have the time spent in a study by the two groups of students. Okay. Which of the following support the argument time spent on studying related to the two groups, group 1 and group 2? The median time spent is clearly higher in G1. Okay, median higher because this is time span. Obviously, the bigger the number, better it is for G2. G1 is higher, median is higher, is about 5 something, here only 2 something, so that is correct. The time spent studying is less variable in G1 compared to G2. That is definitely wrong. G1 is more widely spread, and they also have 2 outlier, 2 very hardworking students, and that definitely is wrong. It should be the other way around. Okay, is G2 less variable than G1. The distribution of time spent in symmetric in G2, but negatively skewed in G1. G1, this is longer, so it's going to be something like this, negatively skewed. It just looks a bit of kind of same. Okay, so you can accept that. So answer should be 1 and 3 only. Do we have an option 1 and 3? Yeah, C. 1 and 3 only. This question is actually in your revision, not revision, in your manual. Okay, the equation is already given that X bar is there, Y bar there, just substitute lah. So your B plus 3.69 of your X bar, which is 3.46, should be equivalent to your Y bar, which is 4.65. Do your maths. I think your answer is C, is that right? I'll recall. This C, people? Can someone confirm? I say typing. What does it say? Yes, thank you, Erin. Next, you have the mortality rate, right? Mortality rate. And you're given the equation, predict 120. So all you need to do is your M is equivalent to 333 minus 33 ln 120. Okay, do the calculation. So you're gonna just 333 minus 33 ln 120. You have 175 point something, blah blah blah. So the nearest value is 175. Huh? Okay, you just need to substitute the 20 inside. You have one question here. You have that the data, and you will key in the data here in your GC. The difference is here. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 data. So obviously your A is wrong, your B is wrong. So the mean is, right, summation of your X divided by N. Your N is 15. Huh? You key in your L1, right? Key in your L1 and then do one var stat. So when you do your one var stat, the summation, I think you'll be getting 464. All right, 464 divided by 15. So both it seems to be there. And you need to take the standard deviation from the SX. So your answer should, SX is, sorry, the other way, right? This is sigma no minus 1, so here SX. So answer is B. Okay, always read SX. Huh? Standard deviation is SX, S for sample. All right, I think we came to the last part. Which are the three types of coefficient that are obtained in a regression? So of course, the coefficient of correlation, that is R, coefficient of determination, R squared, coefficient of regression, that is the value of your A and B, coefficient of your X is not there. Answer is A, B, C. 1, 2, 3. Okay, I think we came about to the end. Any questions? Can you post this file? Okay, right. I will do this in your MS MS Team. MS Team. It takes a while to save the file, so I will do that whenever. I mean, the recording. The file, yes, no problem. Okay, if no questions, the attendance is only about half. We can stop. If you have questions, you can ask. I'll wait for a while. All right, welcome people. Have a good weekend.
Thanks, sir.
Yeah, welcome, Damien. Hello, 9 people. 8. So I thought 8 is C. This is 8 is C. Huh? Why is it 8 is C? Oh yeah, n minus 1. Huh? Yes, that's correct. Correct. Sorry, yeah, n minus 1. Yeah, should be bigger value. Yes. Should did the first one correct. MCQ, the first is always the right thing. Thank you. All right, I think I would stop sharing. Ajay,